The greatest common factor. Our objectives are going to be to find the greatest common factor of a list of numbers, to find the greatest common factor of a list of variable terms, and factor out a greatest common factor. Well, our definition is that the greatest common factor, or GCF, is the largest factor that's common to all the terms that we're considering. To find the GCF of a list of integers, we write each number or polynomial as a product of prime factors. We then identify the common prime factors and take the product of all those common factors. If there are no common prime factors, the GCF is 1. So we have an example. Find the GCF of 12 and 8. Well, in this example, 12 can be written as 2 times 2 times 3. Verify that with a factor tree if you'd like, but 2 times 2 times 3. And 8 can be written as 2 times 2 times 2. Well, if we look for common factors, we have a 2 and a 2 in common. 2 times 2 is 4. Therefore, the greatest common factor is 4. Let's apply that to a list of numbers. Find the GCF of each list of numbers. We have part A, GCF of 6, 8, and 46. Well, 6 can be written as 2 times 3. 8 can be written as 2 times 2 times 2. As we actually saw in that last example. And 46 can be written as 2 times 23. And 23 does not factor anymore. So looking for common factors, seems they all have a 2 and no other common factors. So our GCF is 2. Part B, we have a little more complicated with bigger numbers. Find the GCF of 144, 256, and 300. All right, well, for these, I want to write factor trees for each one of these. So 144 can be written as 2 times, I know it's even, 2 times 72. 72 is 2 times 36. 36 is 2 times 18. 18 is 2 times 9. 9 is 3 times 3. So I could write 144 as 2 times 2 times 2 times 2 times 3 times 3. 4 2's, 2 3's. All right, 256. That's also even, so that would be 2 times 128, which is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. That is 1, 2, 3, 4, 5, 6, 7, 8 2's. 4, 5, 6, 7, 8. All right, now 300 is also even, so that would be 2 times 150, which is divisible by 2, 2 and 75. 75 is 5 and, let's see, 5 goes into that how many times? It would be 1, 15. 5 and 15, all right, which is 5 multiplied by 3. So that I could write this as 2 times 2 times 3 times 5 times 5. So looking for common factors, they all have 2 2's. And that's all, because 256 doesn't have any 3's as factors, nor 5's. So 2 times 2 is 4, so my greatest common factor is 4. Last example I have is 7 and 20, part C. And 7, actually there are no factors of that other than 1 and 7, so 1 times 7. And 20 could be 2 times 10, which 10 is 2 times 5, so 2 times 2 times 5. There are no common factors. But because I could also, I can always throw in an extra 1. 20 could be 1 times 2 times 2 times 5. My GCF is 1. Right. To find the greatest common factor of a list of variable terms, for this example we have 18x to the 4th. 24x to the 5th, and 45x to the 7, we can write these in a factored form as 18x squared, or x to the 4th, is 2 times 3 times 3. That's the factorization for 18, and we have x to the 4th. 24 is 2 times 2 times 2 times 3, and then we have our x to the 5th because it's an x to the 5th term. And 45x to the 7 will be 3 times 3 times 5, it's 45, x to the 7. The GCF of the coefficients, 18, 24, and 45, is 3, because that is what's in common. They have a common 3 factor. And 3 is the least exponent on x, and the least exponent on x is 4. So our greatest common factor is 3 times x to the 4th. The variable, with the smallest exponent, let me just read this exactly. The exponent on the variable in the GCF is the least exponent that appears on the variable in all terms. Helpful hint. Remember that the GCF of a list of terms contains the smallest exponent on each common variable. So if we have the GCF of x to the 3rd, y to the 5th, next term, x to the 6th, y to the 4th, and x to the 4th, y to the 6th, that would be x cubed, y to the 4th, because 3 is the smallest exponent on x, 4 is the smallest exponent on y.